Hello everyone. In today's video, we are going to solve a very interesting problem from magnetism. It's about a flexible conducting loop, a magnetic field, and how the loop changes its shape and lifts a mass. Sounds cool, right? Let's dive in. Yeah. So we are given a loop is made by joining the ends of a flexible, inextensible, and light conducting wire of length 12 with a thin insulating coating. The loop passes through two frictionless hooks. One of the hooks is attached to the ceiling, and from the other hook, a small rubber block of mass is suspended as shown in the figure. Below the ceiling, a horizontal magnetic induction B is established. Now a gradually increasing current is made to circulate in the loop. For all values of the current in the loop, forces of magnetic interaction between different parts of the wire are negligible as compared to the other forces. So we are asked to solve these three parts. So the first part, what shape will the loop wire assume for a particular value of the current in the loop. Find the maximum height up to which block can be lifted. Find the current in the loop to the lift the block to a height h equals L times 1 minus 3 by pi. So first we analyze the problem given. Okay, let's think about what's going on. So the loop is flexible, so it will adjust its shapes under the action of magnetic forces. Whenever the current flows through the wire in the magnetic field, it experiences a force given by F equals I times dl cross b bar. Okay, all right. So the entire loop carries the same current I because it is flexible and here frictionless hooks. Okay. So the magnetic force on the small element can be written as df bar equals I times dl cross b. So the magnetic field is horizontal and toward into the plane, and dl if we do cross product of these two, so the force will be perpendicular to the wire. Okay, so the force will be always perpendicular to the wire in every direction. So the wire expands its length and being a circular shape. All right, so yeah, I have written here f will be perpendicular to the both dl and b bar. Okay, so each side of the loop will form a circular arc and it will be symmetric. So the each side of the will form a circular arc, okay, of radius r. Okay. Oh, all right. Coming to the next part of the question, we have to find the maximum height up to which the block can be lifted. Okay. Yeah. So the when the loop becomes a perfect circle, the block will be at maximum height. So we have to analyze the situation here. So yeah, here the force will be df equals I times dl cross b bar. Okay. When the current becomes infinity, the force will be maximum. Okay. So when the current becomes infinity, the block will be at maximum height here. So yeah, for finding maximum height, we have to subtract small l minus 2r. Okay. So here total length 2l equals 2 pi r, basically circumference. So from this 2r equals 2l upon pi. So the maximum height equals small l minus 2r. So yeah, h max equals l times 1 minus 2 upon pi. Okay, so this is the answer of the second part. So the last part of the problem is find the current in the loop to lift the block to a height h equals L times 1 minus 3 upon pi. So coming to the solution, so we have to find the current in the loop at a given height h. Okay, so the block is being pulled by two tensions in the loop. Okay, so yeah, that the angle between the two tensions is theta, and it making theta by 2 with the vertical. So yeah, now we equating the vertical forces here. 2t cos theta by 2 equals mg, equation 1. So yeah, now we find the tension here. You basically know how to find the tension in a circular arc. Okay, yeah, we have to consider a small element of angle d theta, and it is making an angle d theta by 2 with the vertical, equating the vertical forces of the tension. Okay, 2t sine d theta by 2 equals magnetic force bi into L. In the place of L, I substituted r into d theta. Okay, after solving this, we get tension equals BIR. Okay, we substitute this tension in equation 1 here. Finally, we get 2 times BIR into cos theta by 2 equals mg. So finally, we assume this as equation 2. So for finding theta here, we have to observe the geometry of this arc. Okay, only I am considering one of the arc. Okay, yeah, so this is the arc I have considered of length L, as we know. Okay, and I drawn an imaginary circle to the arc, and this is the chord of length x. Okay, and it is making an angle theta at the center, and theta by 2 with the horizontal. So yeah, this length is r sine theta by 2, and this is also r sine theta by 2. So the total length x equals 2 r sine theta by 2. Okay, and L equals r theta, as we know. Yeah, this is a simple one. Okay, so to find the length height h, we have to subtract L minus this x. Okay, and as h is given in the question. Okay, now we have to find the angle theta here. Okay, yeah. uh, After simplifying this, finally we get sine theta by 2 equals 3 theta upon 2 pi. Basically we substitute 1 by 1 theta values from 0 to 90 degrees. Finally one of the values is the exact solution of this. So yeah, theta equal to 60 degrees is the one of the solution of this exact solution. So now we substitute theta equal to 60 degrees in equation 2. Finally we get current equals pi times mg upon 3 root 3 times BL. Okay, if you found this video helpful, do it a like and do subscribe for more videos. So that's it for today, guys. Thank you.